Good afternoon. Welcome to this webinar on security in the DevOps world. What are the challenges and how to unlock the change? Let me introduce myself. I'm Amaury Leroux, Marketing Coordinator at Rodenschwarz Cybersecurity. And I'm on stage with Edouard Viau, Head of Product at Rodenschwarz Cybersecurity. Hello, Edouard. How is it going?
Hi, I'm good, thank you.
We are happy to welcome so many people today for this webinar, which confirms us in the idea that the DevSecOps topic is an important topic today. Before we start, I want to share with you some technical details. This webinar is being recorded, and you will receive in a few hours the link to access it as many times as you want. Please feel free to ask any question you may have during the webinar, and we will answer them at the end of the session. It remains me to wish you an excellent webinar, and Edouard, I let you start.
Thank you, Amaury. Hi, everybody. So I will just begin with the summary. So we will introduce the DevSecOps and why we are trying to achieve this transformation in the organization. And then we'll speak about the feedbacks that we made about interviews, so product management interviews that we made in the last 12 months, I will say. We made around 50 interviews about this subject to see where the companies are in their transformation, what they are looking to achieve, what are their main challenges, and so on and so forth. And then, how to integrate the DevSecOps culture into some security tools, how to process it, what is our product in order to do so, with a small demonstration on how it could work with a precise process and use case, and then speak about our roadmap and conclusion. So, first of all, what are companies trying to achieve? In fact, we are not deploying to the cloud. We are not transforming ourselves into DevSecOps organization because it's cool, because we need to do it, but we do it to innovate more, to stay competitive. So the main idea is to reduce the innovation cycle in order to test some ideas quickly on the market, maybe to fail on these ideas, but to fail fast, and to shorten what we call the feedback loop. So the idea between the feedback loop is when you create a new software or a new release of your software, you do a lot of hypotheses. You can mitigate the risk by doing some product management interviews, for example, but you are putting some hypotheses and you are not sure that the market will love the way that you produce your software. So the idea is to do not do a big release each year, for example, anymore, but to work with small release to get some feedback and to enhance yourself. So in order to reduce the release cycle, you need to automate everything. It's the only way to make it fast. You need also to build scalable businesses. So scalable means the ability to scale, for example, when a peak of traffic will occur on one of your applications, but also I would say scalable businesses. So it must be doable to have a product which has 100 customers and 1 week after 400 customers without too much effort. So you need to think about it when you are creating your application, when you are creating your business, and not after. And of course, when you leverage the cloud, you pay only for what you use. But as soon as you do this, when peaks of traffic occurs, for example, you need to be able to scale your application instances within minutes or seconds in order to be able to take into account this new amount of traffic. And for DevSecOps, the most important thing is I would say, to break the silos and to change the culture. The main problem to shorten the release cycle is when you have a lot of different departments inside your organization, and that it takes some time to exchange. Yeah, there are too many interactions, and it will be much more efficient to have all these people inside the same team in order to innovate more quickly. It's why, for example, we ask the developers and the operation guy to be on the same teams, or to the developer to take care about ops, to take care about security, because things are not working so much when there are different teams. So, which is important is to change the culture, but if you only change the culture and you don't change the process or the tools used, you'll fail. And if you only change the tools without trying to change the culture, it will be the same result. So it's really important nowadays. So like I said, the best way to reduce your cycle to innovation, your go-to-market is to automate everything, or at least to automate most of these things. And the idea is to, when a small modification occurs, to build a new version each time you make a modification, and do not wait to have, for example, 6 months of new deployment to test the release, to ask you some questions about the security. If you do this, it will be not achievable, in fact. So the idea is, for example, each day when one of my developers will make new source codes inside my application, I will build something new, even if I don't deliver it and deploy it each time. I will go through a CI pipeline, so a real software factory. I will do some tests, and then if I want, I will deploy it automatically. But both the build, the test, and the deployment should be automated. So I will give you some feedbacks about the interviews that we made and what we have seen. So yeah, most of our customers are deploying application to the cloud, and not only storage of data or things like this. But which is important to understand and to remember is that most of the organization deploy to the cloud, but not all their applications. In fact, they have a lot of legacy applications that could be deployed, for example, in a classical data center, and new application inside the cloud. So it's not black or white. Generally speaking, they have both deployment methods, and they industrialize currently their way to deploy to the cloud, their way to configure this new software factory, and then they will migrate the legacy application, or at least a part of this application. So yeah, the idea between to leverage the cloud is to be able to scale quickly the applications. So it will be much more difficult if you do it on your own premise, for example, and huge cost saving thanks to the pay-as-you-go model. Another statistic, so it's not a surprise, but AWS, Azure, and GCP are the most used platform on public cloud. We have also a private cloud usage. We see some customers also that want sovereign clouds, so deploying in some other platform like Outscale or OVH, for example, in France. But yeah, Azure is getting more and more market share. But the main idea to remember is that we see organizations entering into multi-cloud scenarios. Some other to choose only one cloud. But which is important is that, for example, a big company could have several subsidiaries, and one of them could choose Amazon, the other could choose Microsoft, for example, because of Amazon could be more interesting for one thing, for example, artificial intelligence, and Azure for one other thing. And you could say, okay, if I will leverage a lot of artificial intelligence, I would like to take Amazon because it will shorten my go-to-market, for example. But yeah, multi-cloud deployment are important. One of the things is you could choose one cloud and 4 years after you will want to change. So what is important is to do not create so much picking with one platform and to leverage agnostic technologies the more that you can in order to be able to change or to have only one model for multi-cloud scenarios. Is your DevOps process secure? So yeah, what currently the companies are moving, so they make security, but they need to enhance themselves in this field. So they are testing some ideas and see how it evolves. We will dig into the details. But yeah, it's difficult to put this security inside a DevOps teams for some reasons. The main reason is that the developers have a lot of things to do outside of this security. So to take time to put the DevSecOps culture and the security culture will differ, for example, the innovation. And so we need to find the good tools and process in order to do so. And to change the culture is really complicated. In terms of security tools, so we have, I would say, a small bias in this statistic because, for example, when we say static application security testing or dynamic application security testing, not all people really knows what it's behind, in fact. And sometimes they answer to the survey, and after qualitative discussion, we say, for example, do you use a vulnerability management tool? They say, yes, I use Rapid7, for example, and it could be considered as a DAST. But what we see is that, yeah, container security is more and more important since new application could leverage microservices, for example, or at least containers. Web application firewall, maybe we have another bias since we do WAF. People that we are speaking to knows well this market. API management and API protection is more and more important. And we will dig into the details, but for the other products, SAST, DAST, and SCA, we will explain what it stands for, are clearly used by DevSecOps team. And some new application leverage containers. So again, a lot of people say that they use container, but not for all application, not for legacy application, for example, but they begin to use containers with new application. So leverage microservices to break all the monoliths and to cut the different services in different containers, for example, and they will speak with each other, which will be much more easy to scale, easy to use, easy to maintain, and so on. And what new trends, but we don't see it so much currently, is the serverless. So the aims of the serverless is you don't manage anymore any container, any virtual machine, nothing. You just put your code on Amazon, on Azure, on Google, and you say, okay, each time this trigger occurs, please execute this code, and the deployment method is completely transparent for me as a user. But yeah, it will be maybe the trend of tomorrow, but only for some special use cases, not for something that will run every day or quite often on each request, for example, and only on precise use cases. Another statistics are people that, in terms of technology, use Docker, Kubernetes, Terraform, a little bit less sensible, but it's becoming more and more important. So yeah, when they leverage containers, they like to use Docker. Kubernetes for their cluster and their orchestration methods, and Terraform and Ansible to do infrastructure as code and configuration as code. So like I said, SAST, DAST, and SCA are becoming more and more popular for the DevSecOps. So the aims of SAST is to analyze the source code of an application. So it's a white box approach. You have access to the source code, and you will looking for vulnerabilities and flaws inside the source code. And with analyzing the semantic, you will say, okay, I detected something, I think it's a vulnerability. The main drawback, it could be complicated to use this kind of product, but it's important. And the feedback that we had from companies that are using it is you must go step by step. It's impossible to buy a product. So for example, Checkmarks or Veracode are doing SAST, and to say to your developer, okay, starting from tomorrow, you will use this tool on each release, on each application, and so on. You must iterate and fine-tune the product in order to have less false positive, for example. The second important is DAST. So let's say, for example, we see often Qualys or Rapid7 in our customer premise. So the aim is to do not look at the source codes, but to deploy the application in a pre-production environment, for example, and to test some security pattern in order to, in this example, to find a SQL injection. So it's more a black box approach. We test, so we can test in a pre-production environment, but also in production, because maybe you will put in production something without any vulnerabilities, and then one vulnerability will be found one day after. So you must continue to make some tests. Yeah, so DAST is also becoming more and more popular. The problem is that you find a lot of vulnerabilities, but you have also to find the time to correct them, which is a current challenge. And software composition analysis is close to DAST, but it will analyze all your dependencies inside one application or one project. And in fact, without any tool, it's currently quite impossible to say every dependencies that you are using inside a big application. Let's say, for example, you use one framework on top of PHP, for example, to develop an application. The framework will use some libraries, some other framework that will use another libraries that will use another dependencies, and so on. So it's quite impossible to keep an eye on all the dependencies that could have vulnerabilities. And when you use a huge framework, you could have 500, 1,000 dependencies that will all have 3 or 4 vulnerabilities per year. So 1,000 dependencies with 3 vulnerabilities per year make you 3,000 vulnerabilities to handle, to correct, to update the good software, and so on. And it could be a nightmare, in fact. So you must first know your dependencies and then know the vulnerabilities inside them in order to correct them. The main problem is it's not because you buy this kind of tools that you are out of the problem. The tool, like the other, will give you some potential problem, and it's really good because you must identify the vulnerabilities as soon as possible. Yeah, the more quick you will be aware, the less costly it will be to correct them. But it will only point you some new work to do. In fact, some correction to be made inside your own source code or inside dependencies. So it does not solve your challenge to be able to secure everything before putting in production. And yeah, depending on the framework or language that you will be using, you could have a lot of dependencies, and it's really dependent to the technology you are using. So our idea is to bring a cloud native application protection solution. So running in a container, because new applications are leveraging this technology. It's easy to scale. So it will scale with the app and decrease the false positive rate in one end, but also increase your agility and your ability to correct some errors without modifying all the product, for example. So let's dig into DevSecOps and how to integrate inside CI/CD integration. So most of the DevSecOps will leverage CI/CD in order to automate everything inside their software factory. So here in this schema, for example, a DevSecOps will produce some code. So today I will code this functionality, and then we'll commit it inside Git, for example, a central repository. And each time I will make a modification, a pipeline will execute himself in order to do some tests, to build a new version, to do some tests on top of it. And if all the tests are okay, to package a new version. And if I want to, I could also deploy automatically without any human interaction. So deploy the application, but also deploy the security solution associated to this application. So when I say performing some tests, it could be a lot of tests. First of all, some tests about the application itself. So for example, if my developers modify this function, I will have to make sure that this function will continue to work without any functional regression, for example, but also some security tests. So static tests are analyzing the source code. Then you deploy test environment to do dynamic test on top of it. And the good thing is you could test it with and without a security solution associated to it, to make the difference between only your application and your application with your security solution. And then you know your remaining risk to handle. So like I said, some security solutions are used by the prospect and customers. And the main idea is that the web application firewall is really seen in the run phase only to protect the application when it has been deployed. And what we want to do and what we have built with our customers and prospects is something that will also be able to be configured directly in the build phase, for example, and in the test phase. We spoke a little bit about the infrastructure as code. So the aims of infrastructure as code is to deploy automatically and to scale automatically. It's really a way to automate and a way to innovate more. So for example, you will use Terraform script in order to deploy a web application firewall and to make it scale automatically. Then once you have deployed, you want to configure automatically without any human interaction. So you will, for example, leverage Ansible script in order to do so. And what we are showing today is a new era, which is security as code. So the aim is to give the context, to give security information, false positive management, a lot of things directly in the build phase. And asking some new people, like DevSecOps people that really know well the application. So one idea could be to design a general security policy, but to ask something to the developer to inject into this policy. So you could say, okay, you will give me this and this information in order to help me. So it's the aims of Trusted Application Factory with leveraging containers deployed close to the application. So if I retake my schema, one idea could be that the DevSecOps just creates, I would say, a configuration file. In this example, to give us some context, it will commit it close to his source code. And thanks to the CI/CD pipeline, we will take this file, put it inside Trusted Application Factory. We will inject it inside the container and enforce what has been said by the developer. So it's a way to influence a global security policy. And in this example, we speak about context. So context could be the operating system, could be the language used to do the application. So thanks to this context, we will say, okay, if it's PHP language used, I will not protect against Java, for example, so I will have less false positive and so on and so forth. So it could be context, but it could be also everything, a part of the security policy. For example, the developers that are producing API often generate some files, description file about their API, like Swagger or OpenAPI files. We could directly take them, enforce them inside the web application firewall in order to block everything that is not weighted by the developer. It could be context, it could be also false positive management, for example. And one other step that we built is the workflow as code. So the main idea is to directly write code to describe what you want to do on security. It will be used by the most mature and advanced customers, not all the customers. I would say the classical customers will continue to design, I would say, a visual policy, for example, which will be a general policy. So, for example, not directly made by the DevSecOps, but by the transversal cybersecurity team in collaboration to the CISO, for example. So they will make something general and as an input inject some configuration file. But you have to know that you could also directly write with some code the security policy. So we'll give you one example and one small demo. So the context is really the most easy to implement use case, I would say. We want to think this solution step by step because it has been really important with the feedback of the customers to do not have everything to do at the first step, but you could work on one subject and then enhance with another subject. So we think about the different use cases. And so context description, like I said, we want to lower the number of false positives. For example, by saying, okay, my application specificities are this. So I will give them as an input of a general security policy, and it will adapt this security policy. So it will also improve performances because if you don't use some security engines that you don't need to, you will be able to improve the performance, and you will have really a tailored security policy for each application. So when you are in the DevSecOps with the CI/CD pipeline mode, you will write one configuration file that you can see with Trusted Application Factory on the left, and this is the same example on the on the right, and this is the same example on the left with a classical GUI and a human configured it. So as you see, it's only a small configuration file where you have to say, okay, my app language is PHP, for example. So I will do a small demonstration. I will not leverage the configuration file. We are speaking about DevSecOps, but it will be more easy to visualize with a GUI, but you can do exactly the same thing. So for example, I take my PHP application. So I will apply a workflow, so a security policy, the context description one, and then I will give the specificities of this application. So for example, here I say it's a XML API on Linux operating system, developed in PHP and using a SQL database. And I will apply this configuration to my tunnel. Then if I make some tests, some technical tests, so if I send a request with valid XML, I will have an answer, it will work. But if I send invalid XML, it will be blocked because it's the aims, one of the aims of the security engine. Then if I, for example, send valid XML, but with a PHP vulnerability exploitation, it will be blocked because I know that I have some PHP language behind. But if I do the same test with Java exploitation, it won't be blocked because I know that I do not have any risk behind. In this second scenario, so it's a different application, an ASP.NET application. So same thing, I will apply my security policy, context description. And then for application type, I will say that it's a dynamic web page because it's a browser behind. On Windows operating system, ASP.NET language. And this time I'm not leveraging SQL database. So same thing, I will do some tests on top of it. So if I send a classical request, I will say I have a normal answer from the server. It does not be blocked by the security solution. If I test an XSS attack, it will be blocked because I know it's a dynamic page behind. If I test a SQL injection, I know that I don't have any SQL database, so I will not block it. And since SQL syntax is close to English, it could make some false positive. Injection, command injection. So since it's a command injection for Windows, it will be blocked. And just some XML, it won't be blocked because I don't write XML content. So it was the example of context description, which is the easy part, but you can configure everything, in fact. All your false positive, for example, if DevSecOps tests a trusted application factory with his new release of this application and sees that there is one new false positive because of its modification, it could directly configure the product in order to take care about this false positive before putting it in production, which will save a lot of time, a lot of human effort, and will permit to have a faster go-to-market. So currently we have one product in the freemium version. So with the standard security rules, context description, like I said, so the form factor is microservices leveraging Docker containers, the ability to integrate it directly into the CI/CD pipeline to do some false positive exceptions, to monitor the health of a trusted application factory, and to automatically, with an orchestrator, to be able to restart it, and the workflow as code capabilities. Then we will provide some custom security workflow. So the ability to import your workflow directly inside the product and not leveraging our standard security workflow. So it's interesting for people that already use our web application firewall, for example, or people that want to configure a general policy in central cybersecurity team, for example, and ask all the other things to import to the developers. Yeah, the premium deployment, so with the SAST licensing, and then we will provide a GUI, which will be SaaS. So trusted application factories, the security engines are close to the application, but the logs, the dashboard, and so on, you will be able to see them in SaaS. And then some enhancement, for example, in API protection. So like I said, you could import an open API. The idea will be to be able to do some annotation that will be understood by trusted application factory. Like, for example, saying, okay, this endpoint, the answer of this endpoint in my API could not exceed 10 bytes, for example. And if it's more, it could be information leakage after vulnerability exploitation. So please block it automatically. So the developer could tell our products some rules to respect in order to protect more the application. And it's what we call outgoing filtering. So the idea is really to do not focus only on the requests and the vulnerability exploitation, but to be able to detect that someone has broken into the system, it's actively exploiting the system, to block it, but also to give an alert to make investigations. So as a conclusion, we have a central WAF technology that we created more than 10 years ago, that we enhanced since so much time, which is used by several products. So the web application firewall, that could be on-premise with hardware, with appliances or virtual machines, for example. Deployed in the cloud marketplace, like Amazon, Azure, GCP, leveraging, for example, pay-as-you-go concept in order to be able to scale. Deployed in SaaS with Cloud Protector. So here you redirect directly your traffic from your DNS to our infrastructure that we will take care about scaling, updating, and so on. And then you just have to configure it in a few minutes. And so the new product and the new form factor is Trusted Application Factory, leveraging containers, being able to leverage the DevSecOps team to ask them some information. And like we said, to solve the remaining issues that companies have with SAST, DAST, and SCS software. So for example, being able to ask the developer some custom rules in order to virtual patch some vulnerabilities more quick than to have to correct it directly, and being able to put in production by being secure, but without taking too much time. So it's the whole portfolio of application security that we have. And you can contact us if you want to test the freemium version in order to have access to it and to be able to make us feedbacks.
Thank you, Edouard, for this presentation and this demonstration. I now invite you to move on the questions.
Okay, so yeah, we have one question about the pricing model of the product. So Like I said, we have a freemium, which is limited, like all the freemium. So the main idea is that you will be able to use the container to run it for 1 hour, and after it will reboot. So you will be able to reuse it, but it's made to test the technology, to construct your security inside CI/CD pipeline, so usable for pre-production environment, but not in production. Then in production, you go on the premium version, which is based on subscription, and the pricing is made by application and by request. Another question is about the deployment architecture. So it could be deployed several ways. In fact, you could deploy it like a classical web application firewall if you want, like a gateway firewall, I would say, and to put all your traffic to go through this big instance and then to your application. But the more common usage of Trusted Application Factory is to have one instances of this product per application and close to the application. And one example is that it could be deployed in Kubernetes cluster, for example, but not only. And it could be directly after the ingress, and so in line just after the application, or deployed as a sidecar container, for example. One question about the statistics that we made. So we plan to do future statistics and future survey for our customers. Yes, we will continue to do so. It's always interesting to see how our customers and prospects evolve in their deployment in the cloud, in their DevSecOps and transformation and so on. And it's always interesting to see statistics in Europe, in France, to be able to do some different group and do not rely only on statistics from our side. One other question is about the custom rule in order to virtual patch. So I spoke to it just in the conclusion, maybe a little bit more quick. But in fact, the idea is to ask your developers to be able to create some virtual patches. So let's say, for example, I have an application with a lot of dependencies. I need to correct them, but I have too much to correct. So 100 vulnerabilities, and my top management wants me to put in production in 2 weeks. So if I correct all the source code, all the dependencies, I will take so much time. So one way could be to write some custom rules in order to protect against these vulnerabilities and to have more time in order to correct it, but I can put it in production. And to really give visibility around this. The aim of the project is really to put around the table every team, like the developers, the product owners, the CISO, the digital officer, and so on, to share the same visibility. Okay, what risk is remaining? How can we mitigate it quickly? Do we have to wait before putting in production? And since we are the only security solutions that will be both in the build, test, and run phase, we could give this visibility and help to have more secure software with a better go-to-market.
Okay, thank you, Edouard, for these answers. It's up to me to conclude this session. One last reminder, you will receive the recording of this webinar in the next few hours. Please feel free to contact us with any other questions you might have. All the details are now on your screen. Thank you all for your participation. and see you soon for a future webinar.
Thank you.
Bye.